Next topic, flow of electromagnetic power and the Poynting vector. This is the topic today we are going to see. So electromagnetic waves which carry electromagnetic power with them, so that the energy which is transported through the free space to the receiver side by electromagnetic waves. Okay, so through the free space, you are going to transmit the electromagnetic wave, which will carry the certain power. Okay, in the electromagnetic wave. So here we are going to derive the power, electromagnetic power for that by using the electric and magnetic field intensities. Okay, so using electric and magnetic field intensities, we are going to derive the energy, that is electromagnetic power. Okay, so now we are going to begin with the curl equation. What is curl equation? Del cross Nave curl. So del cross E and del cross H, electric field intensity and magnetic field intensity. Okay, so del cross E and del cross H. Already you know this formula, del cross E equal to minus dou D by dou T. அதே மாதிரி del cross H equal to J plus dou D by dou T. Okay, once again. So the verification of the following identity of vector operation is straightforward. There is nothing but we are going to write the identity vector, that is del dot E cross H. Okay, this H dot del cross E minus E dot del cross H. This is the identity for vector operation. So now we are going to substitute the curl equation of del cross E and del cross H here. Okay, del cross E and del cross H and we are going to substitute these two values. Okay, in this equation. So by substituting that, you will be getting minus H dot dou B by dou T. Okay, because minus dou B by dou T, you are going to substitute here. So you will be getting this. Adhe mari, for del cross H, you will substitute J plus dou D by dou T. Okay. Then for a simple medium, you are going to use the parameter, that is epsilon, mu and sigma. Okay, which will not be vary with the time period. Okay, these three parameters will not vary with your time period. So that we are going to apply this three parameter. So that what will happen? H dot dou P by dou T can be written as H dot dou B. Instead of B, you are going to replace the value of mu H. B is mu H. I think you all remember this formula, B equal to mu H. So dou mu H by dou T. Instead of B, you are going to replace mu H. Okay. And then just H here they represented. We are going to write the H as a 2 half. Okay, 2 half value. 2 half value will be equal to 1. So in that manner, you are going to write it. Okay, half into dou mu H dot H. Okay. So the twice we are going to write the half of the term. Okay, which will be equal to 1. So இதுல dou by dou t வெளியே எடுத்துருங்க. Okay. So H dot H is nothing but H square mu, okay, 1 by 2. Okay, just small slight variations we are changing in the equation. And then E dot J. What is E dot J? J is nothing but this one, this term. E dot J play and the term. இதை நம்ம just we are going to modify it. So என்ன term யூஸ் பண்ணா j equal to இந்த j equal to sigma e இங்க எப்படி b equal to mu h அதே மாதிரி sigma e அப்படிங்கறத j க்கு பதிலா ரீப்ளேஸ் பண்றோம். அப்ப என்ன ஆகும் e square into sigma. Okay, so that we are going to replace all this value in the above equation. இந்த 57th equationல h dot dot e by dot e இல்லையா இந்த இடத்துல இந்த வேல்யூவும் இதே மாதிரி e dot j இடத்துலயும் இந்த வேல்யூவையும் ரீப்ளேஸ் பண்றீங்க. பண்ணீங்கன்னா என்ன ஆகும் del dot e cross h will become minus dou by dou t half epsilon e square plus half mu h square minus sigma e square. So likewise, you will be getting, so which is nothing but the point function relationship. Okay, so an integral form of this 58th equation will be obtained by integrating on both sides by taking the surface volume. Okay, இது ரெண்டுக்கும் இன்டெகிரல் எடுக்கிற சர்ஃபேஸ் வால்யூம்ல ஸோ அப்போ எடுக்கிறப்ப என்ன ஆகும் ஸோ சர்ஃபேஸ்னா டாட் ds volume integral for this right hand side. Okay, so here you are going to take separate integration for both the terms. Okay, so here the divergence theorem going to be applied to convert the volume integral into surface integral, because left hand side we are taking surface integral but right hand side volume integral இருக்கு. So to convert the volume integral into surface integral, what theorem will be applied? It is nothing but divergence theorem. Okay, so just to take divergence theorem for the right hand side. So here we are going to recognize that first and second term on the right side of the equation represent the time rate of change of the energy stored respectively. Okay, so first term and second term, okay, which is represented in the volume integral, is nothing but the term which will be changing with the time period. Okay, the energy stored in the field going to change with respect to your time period. Okay, by comparing the equation you can get the uh, last term. Okay, last term is nothing but ohmic power dissipated in the volume as a result of the flow of conduction current density sigma e in the presence of the electric field. So last term is sigma e. Okay, sigma e is nothing but electric field. Electric field intensity with respect to your conduction current. Okay, J. So hence we may interpret the right side of equation as the rate of decrease of electric and magnetic energy stored, which will be subtracted by the ohmic power dissipated as heat in the volume. So this first term, okay. So in the term பார்த்தீங்கன்னா electric field, இது வந்து magnetic field. The electric field and magnetic field energy stored will be obtained in these two terms, that is subtracted by the ohmic power relation. Okay, the sigma e is nothing but ohmic power. Okay, so we are going to subtract the ohmic power from the energy stored in the electric and magnetic field, that is given in this paragraph. So in order to be consistent with the law of conservation of energy, this must equal the power, this power leaving the volume through its surface. Okay, so according to the law of conservation of energy, what will happen? The rate of energy which is leaving will be equal to the surface energy. Okay, so thus we are going to obtain the quantity E cross H is a vector, that is flow power flow per unit area, that is represented by power equal to E cross H. Okay, so power, the quantity P, okay, the power flow per unit area can be represented by E cross H. That quantity is, sometimes we can call it as a Poynting vector. Okay, so E cross H is represented by a Poynting vector P. Okay, we can say that as a power flow per unit area. Okay, or also we can mean it as a power density vector associated with EMF. Okay, so E cross H represent your Poynting vector. Okay. So this equation will represent the Poynting theorem equation. So yeah, E cross H, integral surface integral of E cross H will represent the Poynting theorem. So we can write the this equation in different form. That is integral surface integral of Poynting vector. Okay, P, quantity P, which is nothing but Poynting vector. Okay, so instead of E cross H, you are going to replace by Poynting vector P. Okay, P dot ds equal to, so in that side இருக்கிறத அப்படியே எழுத போறீங்க, but minus sign. So இங்க minus sign இந்த side கொண்டு வரதுனால this side will become positive. Okay, அதான் இங்க represent பண்ணிருக்கோம். Du by du t integral of just you replace the half epsilon e square by we and wm. That is electric field and magnetic field into dv, integral of p into dv. Okay, so p is nothing but sigma e square. Okay, so half epsilon e square is nothing but electric energy density we, and then half mu h square is nothing but magnetic energy density wm, and then p sigma is nothing but sigma e square that can be represented as j square by sigma, that is ohmic power density. Okay, so these electric and magnetic field energy density can be subtracted from the ohmic power density, which will give the Poynting vector P. Okay, so the above equation will state that the total power flowing into a closed surface at any instant equals the sum of the rates of increase of the stored electric and magnetic energy and the ohmic power dissipated within the enclosed volume. Okay, so 2 points concerning the Poynting vector are worthy of note. First, the power relation. It is 59th equation. Before equation. Okay, in the equation, yeah. So will give you the power, total power flow across a closed surface, which will be obtained by surface integral of E cross H. So the Poynting vector is nothing but power density vector at every point on the surface is an arbitrary. Okay, this is the concept of Poynting vector. Okay, which will be normal to the direction of electric field and magnetic field. Here, for the lossless field, you will be obtaining the sigma value as 0. So, on substituting the sigma value as 0, the total power will be getting based on that value. Okay. So, the total power flowing into a closed surface will be equal to the rate of increase of stored electric and magnetic field in the enclosed volume. Okay. ஏன்னா சிக்மா ஈங்கிறது இங்க இருந்தா சிக்மா வரும். ஸோ உனக்கு ஓமிக் பவர் வந்து ஒமிட் ஆயிடும், 0 ஆயிடும் இந்த லாஸ்லெஸ் மீடியம்ல இது ஒமிட் பண்ணிட்டீங்கன்னா you'll be getting only these two terms, electric field and magnetic field density. Okay, so the total power will based on the energy which is present in the electric and magnetic field in the closed volume. Okay, when it is to happen, that is nothing but in the lossless medium. Okay, so in a static field, okay, in a static field, the term we and wm will become 0. Okay, so appa enna agum, in the case of static field, the total power will be equal to the ohmic power because these two terms will become 0. Okay, appa you will be getting only the p sigma, that is ohmic power density alone. Okay, so the total power flowing in a closed surface will be equal to the ohmic power dissipated in the enclosed volume. Okay, when it happens means that is nothing but in case of static field. Okay, that's all. In case of lossless medium, you will be obtaining only this term. In case of static field, you will be getting only this term. This term will be 0. Okay. That's all. This is Poynting vector or Poynting theorem. Okay.